how are we going to harden this network with all the new things that are coming? Everyone's got ideas, but how are we going to do it? What are the things that are going to come into the network? The agenda for today: new services, new performance needs, drop plant component issues, craft errors. What's the financial impact of a craft error? The root causes of drop-related service calls. Do we track them? Do we know how to find them? What are we going to do about them? Solutions, some case studies, and how to improve the drop plant. Sound interesting? Yeah. The capacity per subscriber is a key driving factor at the moment. Frequency allocation changes are coming. Smaller nodes, everyone's talking about making nodes smaller, better efficiency. RF over glass, FTTX deployments. All of these are here. But what about the technology advancements? DOCSIS 3.1, 4K QAMs, 192 wide carriers, MoCA, Wi-Fi, and the performance requirements, they're not relaxing. There's no stopping this. DOCSIS 3.1 is going to increase the capacity performance using going away from the OFDM, PHY, with LDPC, FEC, low density parity check, some that Mark has spoken about. The thresholds do increase slightly. So all of a sudden we're getting 6 dB by using this LDPC. Smaller nodes, more lambdas, the more wavelengths we're getting through, the more things that are going through there, group delay is coming in through the nonlinear optical noise. Low SNR, the further we're getting out, the more we're getting into the drop network, the more we're coming into the house. And then this little thing at the bottom, LTE, how much is it going to affect us? How bad are the home networks out there? I think we've all got a good idea how the home networks look like, but what are we going to do about them? Just a quick one, low density parity check. With this, it's going to give us 6 dB on the SNR. This is great. These were taken from the Broadband Journal from February. So it was perfect timing to get something of this in here as well. We get 6 dB. But all of a sudden, every dB counts in DOCSIS 3.1. What are we going to do with these 6 dB? At the moment, we're going to have to use them in the house. Because the house is where we've got the most problems. That's where we've got absolutely no control. How do we get into a house? We have to talk to them, we have to go in. Ouch. At the moment, DOCSIS 3.1. Are we going to increase the network by adding some more channels down there? If we do, we can actually come into the house. We can actually look at what they've got in there. So that's looking at their wall plates. Oh, this wall plate needs changing. You've got a filter here. You've got a bad network. You've got bad cable. How many times do you get an opportunity to be able to go into the house and have a look at the whole thing based on something else? Not usually. How many times do we want to go into this house? Once. Every time you go into a house, it's causing some money somewhere. What are we going to do though? Do we stop at 85 megahertz? Do we go 112? Do we go full out to 200 megahertz? Every time, does that mean we've got to go into the house again? What about FM? In Europe, in Norway, they've been quite pragmatic about this. We're going to stop FM. Finished. DAB for everything. In Denmark, they're looking at it as well. What are we going to do? FM, just kill it? No, the Danish have taken a different approach to this. They've gone in and said, okay, if we can get 25% over to DAB within 2017, we might shut it down. But let's face it, who wants to shut down something that a lot of people are using? Passive products make up a majority of the connections in the house. F connectors, filters, terminators, drop amps, coax cable, MoCA filters, splitters, F81s, pre-made coax jumpers, HDMI cables, everything else the consumer can put into that house is attached to the network. Are they grounding everywhere? Some places in Europe, they don't use grounding. The UK's lucky, got a grounding plug on it. But what do you do elsewhere? All of a sudden, We want to go down and use 10 megahertz, non-grounded. That's going to be fun for everyone. Just think how many connections are there. A quick one for you all. Some of you already know this. How many drop connectors are in a network with 300 subscribers? 3.5 million? 2.5. Anyone higher? I'd double it. 5 million drop connectors. How can you sit with 5 million drop connectors out there? When I was asked to come to PPC, it was sort of, yeah, but you made drop connectors. There's no flashy lights on that. There's no fun in that. There's nothing, I can't put it into some power and make some fun. But actually, there's 5 million of them out there on a little network. I was presenting in Denmark last week where we also had the same question. And they have 300,000 subscribers. And he looked at me and went, ouch, this is going to be fun. So my next question, of course, was, how many of those are loose? His face totally changed when I asked that question. Why are there so many service calls in the drop plant? Because we haven't got control of it? Probably. Because the consumer's got control of it? Definitely. But what happens in the drop plant? What are the problems? They're intermittent. Poor signal levels. Subscriber error. We change something in the network, how does that affect the subscriber? All of these, all of a sudden, we're looking at a network we don't know. And home networks, how much care do we take for our own HF network? A lot. How much are we taking care of the house? Not much. Do we go looking at the root causes? We're talking about proactive network maintenance. If we could find the root causes and go and say, okay, in this area, it's because they use these wall plates, B0018, 19, 24 models. Fine. What do we do there? Do we go around all those households and change them in one go? What's the best thing to do? How do you avoid repeat service calls? If you think about it, the truck is there, it's standing outside. Would it be easier to let that tech just look through the house, find all the problems? Is it a way to keep that customer there? There's so many problems in a house. Sometimes that one tech wouldn't be able to take it all anyway. He'd need someone else to come in and help him with some of HDMI cabling maybe. Anything. Implementing processes such as preventive network maintenance, having the ability to see problems. I was working closely with one of my old colleagues. He was sitting at his computer, he was on call, and all of a sudden, a red light came up. He went in. Oh, hello, we've got some water coming in somewhere. What? He had just pinpointed 12 modems. All of these 12 modems had a problem with some water coming in because he could see reflections through the modem. Yeah. Great, well done. So what are you going to do? I'll send someone out there. All of a sudden, someone come out there, found the problem. Because it was 12 modems in one go, you can nearly locate the problem to one area. It was one piece of cable that got some water into it. They dropped to RG6 on the ground, done. This is the ability we're getting from DOCSIS 3.1 as well. We can actually look at the modem. You can see how it's reacting, see how it feels. How's your modem doing today? One of the questions in Denmark a lot of years ago was, have you spoken to your child today? Now it's, have you spoken to your modem today? We can actually go out and look at the modem, see what's happening. Service calls should always result in an issue or resolution. If we have this, we can actually help the next customer. And we can actually retain a customer. Customer files a complaint. A service call is generated. The tech comes out, checks the levels. Everything's okay in the network. Because he wants to make sure the network's not the problem. As soon as the network's not the problem, we're going in the house. All of a sudden, you can maybe earn some money on this one. The tech checked the levels at the CPE. The levels look okay. The problem's gone. How did the problem go? Has he tightened up a connector? Has he just loosened the connector, put it on again? Has he turned the CPE off? Has he turned the amplifier off? Has he looked at the amplifier, changed anything in that? All of a sudden, you've lost that ability to go out and see what the actual root cause was, just gone. What about going into the house first? Going into the customer and saying, listen, I'm going to look at what you've got in here first. Right, it looks like everything's okay in here. Now I can go outside. 60% of CPE devices test okay when they come back through a screen and clean. 60% of CPE devices. That's because the tech looks at it and says, okay, I'll change the CPE device. The customer wants something from me. What do I give them? Change the CPE device. It's an easy one. Just means I'll take this device back to me, goes back in the truck, goes back to wherever, gets screened and cleaned, comes back again maybe. On the third time it gets destroyed. All of a sudden you've got money going round and round, but you don't need the actual root cause. Why did it fail? An estimated 6% of the CPE devices test okay. 40% are defective. Looking at that, that's quite a lot of modems that actually should have been there from the start. Drop plant issues and the root causes. Bandwidth limitation, craft errors, connectors left loose, moisture migration, and poor materials used. What do they result in? Poor return loss, higher attenuation, reflections. Bit error ratio goes, MIR goes, impulse noise, RFI, CPD. We all know these abbreviations, but what does it actually affect our network? And what are the symptoms? We get reflections. Signal to noise ratios are gone. Ingress, egress, modem repairs, set-top repairs. The worst thing of all is service calls and annoyed customers. Going back to a customer 2-3 times, what happens? That customer's going to find somewhere else if they can. If they can't, they're going to go around saying, I've got this service, don't really like it, but I'm forced to have it. Are we looking at the service call statistics? How do we track service calls? A lot of places it was a service call, customer's happy now. Why is the customer happy? How should we track them? Can we use this data? How can we identify the root cause? Analysing cumulative effects and proactive network maintenance. All of these add to the bundle we've got. There's so many tools we're getting in DOCSIS 3.1 we can use. There's so many tools we've already got. We've got customers out there that give us the complaint, the television doesn't work. If you think about it, before we had reflections on analog. You could actually measure the distance and find out where the fault was. We're getting this again, the ability to actually see where the fault is, see where problems are. Proactive, go in and talk to the customer. Phone a customer and say, listen, your neighbour's got great signal, yours is rubbish. Could we come in and have a look? Of course. Usually you don't get a no when you say you want to help them. Loose connections. 25% of all outdoor connections are less than finger tight. I was on a network that I've actually worked on, went out and tested every single connector, just for fun. 26% were loose. Were they tightened when I was there? Yes. We all had torque wrenches. Are they tight now? No, they weren't. What's happened? How can you tell? The factor is 25% are going to be loose. 50% of indoor connectors are less than finger tight. How do we stop that? Can you look at a customer and say, oh, by the way, take the torque wrench out and just tighten up just to make sure everything's okay. Just don't do it on the back of the CPEs because they don't really like being tightened up that much, just in case. You can't really tell it to a customer, can you? How are you going to tell them that? Are we going to send a tech out every single place? You never know. Maybe one day. Moisture damage, things installed incorrectly or they're left loose, poor quality materials, not installed on coax correctly, craft errors. One of the things we're also getting is theft of service. As we go digital, we can control this a lot more. Lack of training and subscriber self-installs. I thought the idea with the new micro was good. This is even better. Imagine if this would work. Some customers believe this is how you make a splitter. Great. And they really do believe it. Here's some more from my catalogue of horrors. I like keeping these every once in a while because it just gives people to look at what actually is in the house. Water damage, bad compression, dielectric too far forward, inner conductor too long. They do get worse. On one of the courses, someone said, the longer the inner conductor is, the better it is. I'm glad you're all laughing. It makes more of a... For the dielectric too short. We all know it should be 75 ohms. As soon as you change this, it's not 75 ohms. Why do we do it? You can actually see these things. Braid coming out the back of a connector. We're going into the Eastern European segment where tape is often used. Nothing wrong with it. It does work. This will support everything, but we're looking for a dB every time. All of a sudden, 1 dB does make a difference. Indoor passive used outdoors. Crimping wrong. Tape again. The wrong connector used. Crimp connectors, crimp totally flat. A twist-on connector crimps. They've probably tried to compress it and found out that didn't work, so we crimp it. And the last one at the top is the best. That little piece there is a nail. Someone has invented a universal connector with a nail in there. So PPC will take it to them, and we might adopt this, never. But we're going to start sending nails with every connector. Then you can just put it in and make sure it fits. In the house, things are amazing. I love pictures like this because it adds to that effect. Yeah, but what's the next thing they're going to do? I can't wait to see the next thing a customer's going to do, or a tech for that matter. What does a service call cost? Anyone want to guess? If you add a total cost, I've just been playing with numbers here and said, okay, 80 quid, all in all, for everything. I think some will say that's lowball, some will say it's high. But let's go quickly through it. Okay, what's in the drop plant? 243 million in the drop plant. 275 million going on the CPE. Then you've got the other parts, customer errors, and distribution network. Okay, this is 8 million service calls. The average allocation of connector related is going to be 7%. That's 44 million just on a connector related issue. It does add up. There's 5 million out there. But that's pretty bad. If we look in at the CPE, 6% are going to be connector related. We just don't know it. This data, luckily, has come from Comcast, who actually collect data. They want to know where the root cause is. They don't want to know, oh, it was in the house. They want to know, okay, was it F connector number 1, 2, 3, 4, 5 after the CP, before the CP? Where was it? It makes sense all of a sudden. This is a budget number that goes straight from the bottom line. Ouch. If you talk to techs, they say, yeah, but we need to look after our jobs. Yeah. So does that mean you put errors into the network? No, it doesn't. It means you make it as good as possible. Then you might be able to get some more money out of this. If you could go back to the CFO and say, listen, I've saved you 38 million by doing all of this in the network, all of the techs are doing this, he might start clapping his hands, but he might say, why didn't you do it before? Let's go into a few of the things. Coax cable. We've had coax cable for years. That cable is in their home. If we're lucky, it's got a solid center conductor. If we're not, it's braided. What's the current condition of that cable? Has it been moved around? If a cable's just lying there, it'll probably work forever. But does it get moved around? Probably. Some people want their television moved around to a different place. How old is it? What's the bandwidth performance? If you look at some of the old cables, they didn't even say a bandwidth. It was a piece of cable. It would transmit signals. We need to know that information now. Does the signal level calculate to the distance? How long is a piece of cable in a house? They're elastic measurements. We need an amplifier on it, maybe. Why do I need an amplifier in my house? You should deliver the right signal. Ugh. Good arguments, but how's the shielding effectiveness of and transfer impedance of this piece of cable? Is there LTE protection on it? We can do everything in the network, but in the house, if LTE comes in, it comes in. How do we stop it? Can we force customers to use the right cable? Can we help them? It would be an idea. Let's talk a little bit about screening. What is screening? We all talk about it. All screening, we've got to have a lot of it. How much do we need? And there's two types of screening. There's screening above 30 megahertz and below 30 megahertz. Above 30 megahertz, it's like having a hole in the roof. Water will drip in through a hole in the roof. If you have a problem with the screening, it will come in through the cable. You cannot stop it. But it also go out through the cable. The lower we get, the more we're going over to the DC world. So all of a sudden, it's not just a hole. It's actually something that gets induced into the cable. So if you think about it again, when it rains on a metal roof, you're going to get condensation inside. It's going to drip as well. Same effect in the end, you get water into the house. Comet tubes. The easy way to test screening efficiency and transfer impedance. There's quite a few that have these now and would love to test any piece of cable you throw at them. It's a nice thing to have to look at a piece of cable and say, this is a good piece, this is a bad piece. How do you define good and bad? You go looking through the classes. Just a picture of a little longer comet tube. We love getting anything in. A jumper. We will willingly test the jumper and give you a piece of paper back. On this piece of paper, it doesn't say pass or fail. It just says, here's a piece of paper with the measurements of this article you sent us. We don't want to do anything else. We will not go in and say, this is good, this is bad. That's not what we want to do. We just want to measure it. The test lab in Denmark tests about 200-300 pieces a month. So we're testing 10 pieces a day just to see what they look like. We just deliver these back. It's one of the services we do. Having this information could be vital. We've tested cable that says A++ that comes down to be a B. Testing like that hurts. Because we know where it's going into the network. We know how much effort we put into an A+, just an A+ cable, to make it A++. And all of a sudden we're testing it as a B. These are the old classes. They're being adapted again. A++, 105 dB. Is that enough for everyone? 95 dB screening, is that enough? 85? What is enough? How close are you going to have that device that's making a noise? Too close, and you will need the 105. Looking at some of it, distance to an LTE device, 6 meters away, you're going to need 79 dB. That's class B. 3 meters away, how many houses have got a piece of cable that's 3 meters away from a handheld BlackBerry iPhone? Quite a few. Are we going to be able to go to 6 meters away? I think there's only a few people in this country that have got 6 meters to a piece of cable. And one of them lives just down the road. She's got quite a few houses, quite a few rooms there. So maybe she has the ability to do it. We will never have the ability to have 6 meters to anything that could make a noise. So what do? Do we say we go up to A+ or A++? Where do we go? And how do we make sure they're A++, especially in the house? Prepping a cable. These two are actually prepped by a tech. The top one is absolutely useless. He's hit the dielectric, he's hit the foil, changed the impedance, made it worse. This went from an A+ to a B. When it was done properly, it's an A+. And that's just on the end of a cable. What happens if we use the wrong cable? All of a sudden we're out of class. Passive components. Splitters, F81s, Terminators. There's a growing concern with DOCSIS and MoCA. How many of these components are hidden? How many F2Fs are hidden in walls? How many Terminators are hidden? How many splitters are up lofts, basements, in walls, behind wherever they've put a new wall up? What do? How do we come to these? The only chance is putting a new network in. Who's going to pay for that? How do we tell the customer, listen, we're going to DOCSIS 3.1, we need you to change your internal installation? I don't really care. Yeah, but you won't be getting your signal. It's not my problem. Do you want to deliver it to me? How? Catch-22 again. Which way do we go? Would it be better to tell them up front? Probably. MoCA. It's winning quite well into Europe at the moment. It's an ideal solution. Stouffer in Denmark are adopting it. They want to use it. It gives them some abilities in a house where there's a lot of Wi-Fi spots. All of a sudden, you can use this and put different places in. You're still keeping the network alive, and you're using coax. Tap port terminations, drop savers, they all improve noise performance. Cable equalizers, cable simulators. We're getting that last dB out of the network again to make sure all the levels are okay. Drop amplifiers. A critical part to network performance. Should they go flat? Should they be tilted? Signal levels have to be analyzed and use the gain wisely. Don't use gain to cover up for other problems. Some techs will go out and find the nearest amplifier. I need 3 dB in the house. Oops, I got 3 dB. What have you just done to the network performance? You've totally wasted it. Active, passive return paths. Bandwidth and drop amplifier location is becoming critical. How do we ensure this in the house? MoCA's coming, DOCSIS is coming, LTE's here. What do? All of a sudden we've got amplifiers in there that can give us some problems. Is there a bypass port for the DOCSIS device? So that'll always work. F connectors. There can be as many as 40 connectors in every home. Loose connectors, moisture migration, getting to connection points, they're the root cause of a lot of problems. With 5 million of them out there, of course they are. Loose connectors resulting in loss of ground. create significant reflection, ingress, egress. How do we stop a loose F connector? Easy, tighten them all up. But 25% will be loose, even in the outdoor plant. You can use proactive network maintenance. Go in and find these loose F connectors. Loose F connectors are an amazing source of information. Some days they'll work, some days they won't. As you go past them, you can actually do this, and you'll get connection, won't get connection. How do you stop it? What are you going to do about it? Tighten them all up? Yes. The only way to do it would be to tighten everything up, or ensure you never ever lose connection between the nut and the body. Loose connectors, they give these problems. These two QAM pictures, the top one is how it should be. The bottom one doesn't look too good. Anyone can see that. This is just one loose F connector. What's the customer going to do as soon as the picture looks like the one at the bottom? They're going to call. If we just take, okay, that might cost us $40. What did the connector cost us? 20 cents? All of a sudden, a 20-cent connector has cost $40. Expensive. All we need to do is tighten the connectors that are out there in the network. Yep, there's your new tech. Self-install kits, do they come out into the networks? Yes. Who's going to attach them? She is. If we're lucky, it's this guy that's going to attach them. But he's going to take that self-install kit apart, make one of his own instead. Oh, you've got this guy. He's going to actually go and help his neighbours as well. So he might actually make his own kit and go and help his neighbours. Or him. What chances have we got? LTE interference. We're lucky to have a lab in Syracuse that can actually measure LTE interference coming into their network. So they can sit there and play with LTE all day long. The only thing they can't do is use their mobile phones on LTE. So when they find out there's been a problem, their mobile phone gets kicked off the LTE network for 24, 48, 72. We're up for about 190 hours. We're being kicked off the network. But we should stop playing with their signal, probably. LTE interference coming in. How do we stop it? Again, screening, making sure the network is tight. This is a good network. Nothing coming in. This is LTE. There's quite a significant LTE signal coming into a network, just with a loose F connector. Imagine, transpose this and put it into your channel. Nice. That's really what we want. All of a sudden, we're having to notch out for LTE.
I've got a loose connection in this system right now, and if I turn my 4G phone on and tell it to look at the email, it's looking at it now. We can see all of the carrier coming in. I put it on max hold, and we can see just how much and how wide this thing is.
That's from the lab. The signal coming in was higher than the signal going into the set-top box with just one loose F connector. If we tighten the F connector up, which is that one there, everything works fine. In the end, we moved Mike, Lawrence, 8 meters away. It was better. We didn't get as much signaling, but we were still getting signaling. LTE's out there. How do we stop it? Common F connectors. We can tighten them up. Tighten them in the network 30 inch-pounds. We've known this for years. Still 27% less than finger tight. Techs will frequently finger tight. They're finger tight. I'll come back to that one. Go somewhere else. I'll remember to come back to it one day, maybe. What about indoor connectors? Subscribers install them, self-install kits, wrenches are not used, 50% are loose. How can we change this? Do we need torque enhancing grips or some way to ensure that they're never going to lose connection? There's strategies out there, there's things you can use to stop this. These videos don't seem to want to work. These two videos would have shown a loose F connector and how you stop it by just making sure they don't loosen. HDMI. A HDMI cable, what's that? Do we track HDMI service calls? Do we just change it out? Do we know the level of performance for a HDMI cable? Shielding, holding retention, contact structure. Have you ever tried to put a HDMI cable up, leave it there for a while, eventually it'll work itself loose? Just very slowly. It only has to loosen 2 millimeters and you're going to lose one of the pins on the HDMI cable. Would the installed base of cables support the growing bit rates that are going through HDMI? Will we have to change those out again? And back to shielding. Where's the shielding on that? The shielding is actually a piece of cable running through here that goes up and connects to here. That's the shielding. Talking about pin 19. Just a few millimeters will make sure that pin dies. And that's in the HDMI standard. It has to do that to make sure that all the connections are established before you attach power to the HDMI. It's in the standard. What happens if it just loosens a little bit? No signal, no picture. What does the customer do? I've got a good idea, and it's a phone number to their supplier. These are all just facts. This is an eye diagram of the HDMI. If you look at this, it should have clear pathways in everything. You should be able to see the signal actually running through. It doesn't here. It converges and becomes a red mess. This is going to cause problems with bitrate, handshakes. These cables are out there. What do we do about them? How do you improve DOCSIS performance just by passive devices? If you go in and look at an isolated network, for us an isolated network would be a hotel network. It's a perfect place. You can get into every single house. We can play some really good games. We can loosen every single connector and see what happens. It's quite fun to see, actually. If you put Mocha on that, you can actually see it all the way through the network and watch every single person's Mocha. Great. Improving signal-to-noise ratios, reducing impulse noise, reduce ingress, egress, reduces service calls. This was just one network we went into, checked everything, 887 connectors. 724 were tight, 163 were loose, 18%. That's better than we expect. Were we happy? No. We tightened them all up, or changed them for a connector that won't lose that. We did that there, just by tightening connectors up. That's quite an improvement. Code word errors, trial period, that's quite an improvement. Documented improvements again, just by tightening up. This is what the network looked like. We tightened up, now all of a sudden you can only see the cable modem carriers. That's what it should look like. Tighten the network up. Modem flapping. Every time a modem goes out and talks and says, listen, I need a new configuration because this is really not working for me. It's going to be worse in DOCSIS 3.1 because they have the ability to go backwards and forwards and talk quite a bit. More network traffic for nothing. Tighten up, it'll reduce it. Upstream power reduction. The lower power you're pushing through a modem, the better it's getting in the network. You're not having to force so much power through the network. You're making everything better. Identify root cause, P&M, scouting. Go out and look for these problems, find them. Root causes, product, process improvements, even to find one technician that has a problem with a tool. You can actually use this. So if it happens every single place, he might have a compression tool. You can go and look at that. It's great. Quality components, improve the noise performance throughout terminating unused ports. It's an easy thing. Put a terminator on it. There's a lot of opportunity we've got in DOCSIS 3.1. How are we going to do it? We need to find the strategy. We need to have an idea. Where are the band splits going to be? 1 year, 3 year, 5 years? Will we have to go into the customer in 1 year, 3 year, 5 years? Maybe. What's the rest of the world doing? Because that's going to tell us what we can do. No one wants to make anything that no one's going to use. Improving the quality of passive devices, reduction of craft errors, results in reduced service calls, reduced churn, lower OPEX. Thank you.